Thank you for joining. My name is Justin Sears, and I lead product marketing at Lucidworks. Thank you for joining today's webinar titled Question Answering and Virtual Assistants with Deep Learning. Our presenters today will be Sava Kalbachou, who is an AI research engineer at Lucidworks AI Labs, and Andy Liu, senior data engineer at Lucidworks. Sava and Andy will be giving an overview of question answering solutions in general, and also a preview of Lucidworks QA functionality currently in development. They will show some demos and examples. Even though those examples are not yet GA, they will be this summer. So if you like what you see, reach out to us and we're happy to schedule a meeting. During the presentation, send in any questions you have and we'll answer those in the last 10 to 15 minutes of the scheduled presentation. You'll see at the bottom of your screen there's a Q&A blue link in the lower left. Use that to send in questions. Briefly, Andy and Sava are members of the Lucidworks AI Lab team led by Chao Han. The Lucidworks AI Lab team focuses on AI initiatives to incorporate into the Lucidworks Fusion platform, especially research and product improvements that incorporate deep learning methodology like what you'll see today. So without further ado, let me hand it over to Andy Liu to start the presentation. Remember to send in your questions using the Q&A link in the lower left of your presentation portal, and we'll leave plenty of time to answer those at the end. Andy, please get us started.
Thanks, Justin. Yeah, thanks everybody for coming today. And what I'd like to do first is just discuss some of the current QA solutions on the market right now, just to set the stage. If you've looked around, most of these QA solutions are basically chatbots, which are comprehensive workflow building tools with a UI. So users have to manually provide examples, specify intents, and build ontologies, and use a lot of these rule-based approaches, which generally require a lot of manual work. And if you look at these demos for these solutions, most of them are for booking hotels and restaurants, and these are domains that have a limited number of possible questions, which is possible to cover using these manual rule-based approaches. However, for more complicated enterprise use cases, these solutions are lacking because your coverage will be too low, and you'll leave far too many questions unanswered. In contrast, our QA system, the QA system we'll be talking about today and I'll be introducing is information retrieval based, and we can find accurate answers in indexed documents to fully utilize your company's existing knowledge base without the need for expensive configuration or manual work. So the solution that we'll be introducing today is specifically an FAQ solution. So you can think of an FAQ solution as a system that will recommend answers from a pool of frequently asked questions. And it could also find similar questions that have been previously asked. In the case where you don't have frequently asked questions available, we do offer a cold start solution. So I'll go into that in more detail in the next slides. Some examples of different business use cases. One big one is the call center. So if you have a call center or support tickets, our FAQ solution can power search or virtual assistance on a help or contact us page, which will help users find answers themselves and reduce the load on your call center. So the same system can also be used to drastically improve the efficiency of your customer support team, and they can easily find solutions to solve problems. In the e-commerce domain, you can implement an FAQ solution to answer questions about a product, so similar to what you would see on an Amazon.com product page. For enterprise search, we can also extract questions and answers from Slack and email conversations. So, you know, a lot of these large enterprises, people have asked the same questions over and over again, and the answers are already captured in an email and Slack. So, so let's reuse that information. Let's find a way to provide a way for users to find answers to their questions. If you don't have an FAQ and you just want to improve search for long queries, you can use our cold start solution. So our cold start solution utilizes word embedding methods to capture semantic and contextual information for long queries or natural language questions. This cold start solution doesn't require FAQ training data. Instead, it can use word vector training combined with Solr scores with our provided query pipelines. Again, I'll go into more detail in the next slide. So what are the benefits of using our solution? So we actually conducted a comprehensive study comparing unsupervised models, traditional LTR models using XGBoost, and our proprietary deep learning model. In this chart, we show the accuracy for each model while varying training data size. Surprisingly, even with small training sets, deep learning still provides the best results without the heavy feature engineering required in the traditional LTR models. You know, some of these features are like parts of speech tagging, named entity recognition. A lot of these features are pretty heavyweight and hard to extract. One interesting thing to note in this chart is if you look in the third group, we ensembled our XGBoost model with our deep learning model, but didn't get any lift compared to deep learning alone. So this indicates that the parts of speech tagging and named entity recognition information that I was just talking about is already being incorporated into the deep learning network, and it's being done so automatically without all of the hard manual work of feature engineering. Another thing to note is that if you don't have any FAQ data and you don't actually have a ton of existing textual data sources to train our cold start model, we can utilize pre-trained word embeddings like GSE and fast text embeddings to borrow information from other data sources. Our study shows that if we combine the Solr score with these dense vector results from these pre-trained embeddings, we can provide a pretty significant accuracy boost. So let's talk about the FAQ solution in a little more detail. Our solution includes two key parts, the model training part and the query time model inference in Fusion. So model training is performed in a Docker image. So Docker is the way that we distribute this training module. The deep learning and word vector training modules and configuration UI are provided as part of this image, and they could be used on-premise or in the cloud. After training is finished, the zip file, which includes the model and associated files, will be generated. The model is basically an encoder, which transforms documents into digital vectors, which is used as a powerful and accurate similarity measure. Or on the right side of the slide, the runtime part is performed in Fusion. To deploy the model, you just need to upload the generated zip file to Fusion and use our provided query pipelines to conduct real-time neural search. The nice thing is that it usually takes only days rather than months from training to implementation. So we've done a lot of work to try to make this as easy for everyone to train and deploy their models. In the case where you don't have any FAQ data, you can use our cold start solution, which uses our word vector training module to learn the vocabulary contained in your company's sources of knowledge. So even if you don't have your data organized as frequently asked questions, we can use your existing sources of text in your enterprise to learn your company's specific vocabulary. At query time, it uses our provided query pipeline to combine Solr and document vector similarity scores. So you're able to kind of blend between vanilla Solr and our document vector similarity scores. We suggest capturing user feedback, such as document clicks, dwell time, and conversions on your search portal, which is really easy to do using Fusion's App Studio. After collecting user feedback data as Q&A pairs, the feedback can be used as training data to start the FAQ training workflow. Just a few more additional highlights for our training module. We have an autopilot mode for the non-data scientist. So autopilot mode provides automatic parameter tuning and model selection so that a non-data scientist can run the module and get state-of-the-art results with minimum work. We also have an advanced user mode, which exposes parameters for tuning by data scientists, so for the expert users. And the nice thing is that comprehensive evaluation metrics are computed at each modeling step so that you can easily compare different models. One additional thing to note, too, is that the training can be run on GPU-enabled machines as well as CPU-only machines. The GPU machine training is orders of magnitude faster than the CPU training. So we recommend running your Docker image on a GPU-enabled machine. So one of the biggest challenges of using deep learning for search is the problem of runtime performance. Full-text search engines like Solr aren't really designed to handle dense vectors efficiently. So we actually did some tests using Solr to perform brute force naive dense vector search, and it averaged around 7 seconds per query. So that's not tenable. We have addressed this problem with our optimized query pipeline in Fusion, which is built to enable fast runtime dense vector search. So the table on this slide shows a performance and accuracy comparison between Solr and the Keyway solution pipeline. So using plain vanilla Solr, and this is without any deep learning and dense vectors, you can see that it's pretty fast, at 65 milliseconds, but it yields poor accuracy for these types of long natural language queries. So alternatively, if you use our optimized query pipeline, you can get search results back in under 200 milliseconds. So we've spent a lot of time trying to optimize and use different tricks to optimize both the performance and the accuracy of our dense vector search solution. In particular, there are two implementation options you can choose. So the first option is to use Solr to retrieve the first 500 results. So just imagine using Solr to perform a big OR query for all the terms that are contained in the input question, and just retrieving the first 500 results. And then we use our deep learning model to perform re-ranking. So that's the first option. The second option, which is even more accurate and fast, is that our solution provides an embedded clustering layer within the deep learning model. So at query time, we decide which cluster is closest to the current query by comparing it to the cluster centers, and then we retrieve all documents within the cluster and re-rank using the model. So right now I'm going to hand it over to Sava, who's going to talk a little bit more detail about how this solution actually looks within Fusion.
Yes, thank you, Andy. Hi, all. And let's take a look on how this is incorporated into the Fusion, and on a couple of examples. The starting point is a new index stage called TensorFlow Deep Encoding. In index time, it encodes answers or previously asked questions to the dense vectors, clusterize and compress them. It uses TensorFlow model that was exported from the training module. In most cases, you just need to specify an appropriate feature field with text content that would be encoded. Other parameters are optional to change. On the right side of the screen, you can see simulated results that contain document vector and its compressed version. This compressed version is used for faster retrieving. Now let's check query stages. The first one is quite similar to what we just saw, but it encodes and clusterizes incoming questions. Number of clusters can be used as a separate raw query parameter. It might be incorporated on UI to give users more control. If number of clusters field is set to 0, then pipeline works as our option 1 implementation. So if you use Solr text search to get like first top 500 candidates, and then use deep learning model for re-ranking. If number of clusters field is set to 1 or more, then option 2 implementation is used. Documents from the same cluster as query cluster will be returned for further re-ranking. Next query stage is called vectors distance per query document. Basically, it just computes some distance score. In our case, it's cosine similarity as a default value between obtained query vector and returned documents vectors. It returns vector distances as an additional field in the results for each document. This stage is optional. It allows to ensemble different scores by using a variety of mathematical expressions. So, for example, we can combine Solr score with vector distances, which give us more control and might lead to the better results, especially in the cold start mode. Finally, we just need result document field sorting stage. It just runs results based on vectors distance or ensemble score. Now let's take a look on several examples and compare results from just Solr and from our FAQ solution. Let's start with finance dataset. This dataset has FAQs about investment, mortgage, and credit card. Here you can see the difference between results for a question how to compute gold value. Solr fails to provide good answers in top because it basically counts exact token matches to rank results, whereas our FAQ solution is capable to summarize text content in the deep, dense vector representation, so it can find semantically similar answers or previously asked questions that Solr cannot. Like this one, semantically similar question, how do you measure the value of gold? Yep, sorry. Here's another example. Now in e-commerce domain. The question, any screen protection, is asked against one of the phone cases products. As Solr relies on exact token matches by default, it cannot handle this example. It cannot match two similar words like protection and protector without synonyms list provided. Also, the previously asked question contains a spelling mistake in the word screen, additional E. Despite on this spelling mistake, our FAQ solution is able to understand the context and provides the appropriate QA pair in the top of results. Now let's move to the insurance domain and check what kind of UI might be built on top of this FAQ solution. So, for example, once question is asked, user might see similar previously asked questions in the left column and open corresponding answer by clicking on one of them. Or they can just jump straight to the right column with returned answers. In this case, with a question like, can my wife drive on my insurance? Model can really infer context of the question from the phrase drive on and suggest results exactly related to the car insurance, but not for any other kind of possible insurance policies. Moreover, it can understand the terms like wife, husband, spouse, fiancé, or girlfriend are synonyms, again, without any additional synonym list provided. Here is another example with the question, is it required to have home insurance? Deep learning model can not only understand that home insurance and homeowners insurance are the same thing, but it can also infer that such constructions like, is it required, is it legal, is it mandatory, and even can I own a home without, are similar things. So as you can see, deep learning power research is capable to provide much better results than regular token-based search. It can really understand the context and find good semantically similar results for incoming queries. Thank you, everyone, for attending this webinar. Please feel free to ask any questions.
Thanks, Sava. Thanks, Andy. I've been watching the questions that come in. We had a couple questions about source documents. Let me start with one of those. Is it possible to use your own documents indexed into Lucidworks as responses to questions in the QA system? Who'd like to take that one?
Yeah, I'll take that. So absolutely, this is how our system is designed. So everything that so this QA system still uses Fusion as the backend store for all the data. So so if you have answers to questions, for example, a knowledge base that you've indexed within Solr or within Fusion, we can take that data from Fusion and import it into the training module and then train the model, and then the model gets deployed in Fusion and runs on top of that data that's already in Fusion. So so our solution was explicitly designed to be able to handle your own index documents.
And then, Andy, another one maybe related to that. I assume the same thing is going to be true for documents that are in external stores or databases? Is there any difference there?
Right, so it depends. So, so our solution is an FAQ solution, which finds answers that are in the form of natural language. So, so when we talk about databases, we need to make the distinction between structured and unstructured data. So, so this solution works on unstructured data. There are other QA solutions that work on top of structured data. So, so think of there's a whole field of research that that seeks to convert questions into SQL queries. So, just want to make this distinction. This is not that. We don't actually translate questions into SQL queries, but if you have an external database that contains a lot of unstructured data in the form of like knowledge documents or FAQs, we can easily import that data into Fusion and take advantage of the solution.
Lots of great questions coming in. Let me ask another one about language. Question, is this as effective in Spanish or Italian, for example?
Yes. Yeah, I can. Okay, sorry.
Go for it, Sava. Yep.
Yeah, thank you. Well, yes. Basically, it's language independent because it works in some deep vector space, right? So, yeah, it just requires vocabulary and some training data, and you can train the model for it.
Excellent, thank you. Let me ask a question here. One of the attendees said, when a customer uses VA, they tend to write long queries as compared to search. Question number one related to that, do we need to create two models, one purely for search while another for VA?
So by VA, I'm assuming question QA. So
I think I'm going to guess that's an abbreviation for virtual assistant.
Oh, virtual assistant. There you go. Yes. So our solution is optimized for longer natural language queries. So there are actually pretty simple things that we can do since Fusion is so configurable, where we can use different models based on how long incoming questions are, or just use different tricks on the front end to route the question to different models. So if you're doing something that if the user is asking lots of short queries, and I'm just making this up, but say for short queries, regular vanilla keyword search is good enough. So there's ways within Fusion in the query pipeline to configure it such that, okay, if the query is under this many words or this many characters, use this simpler model, and then if it's this longer, more complicated question, then use the FAQ deep learning model.
Excellent. Here's another one. Here's one on classifying intent and training the intent model. The question is, how do I classify intent and train the intent model? Do you really need a brand new component? I don't know if that question is clear enough. Can either of you take that one?
Yeah, I mean, I would say that, and Sava, you might have a different answer to this question, but I would say that since we're using a deep learning approach, a lot of these multi-staged ensemble Q&A or query intent models are it kind of subsumes them, and like what I was talking before, the deep learning model kind of captures a lot of information that you would have normally had to do by hand in the form of feature engineering. So I think the hope is that the deep learning model can capture some of these elements of query intent when it's doing its training. I don't know, Sava, if you had anything to add there.
Yeah, generally, yeah, I agree. But even if you need to improve your experience and introduce an intent classification model, there are other possible to use jobs in Fusion that can train such intent classificator, and you can incorporate them to the query or index pipeline that you already have with the FAQ solution.
Here's a great one that maybe follows on the question about query intent. How easy is it for a business user to train a model in Fusion?
Model training is outside from Fusion. It's in a Docker container. It was done because basically we're using some deep learning libraries, and in many cases it would be run on GPU. But it's kind of a one-time job, or you can sometimes update the model. But it's done again outside from Fusion, and then model just exported to Fusion. Usually it requires just a few days to get started using this already trained model in your query pipelines.
Another one. Can I combine basic keyword search with this FAQ solution?
Basically, yes, because the implementation option 1 that we discussed actually works in such way. It firstly retrieves, for example, 500 candidates based on a regular keyword search, and then rank them by using deploying model. And I also showed the stage that allows you to play with scores and use different mathematical questions to get a good ensemble that would work best for you.
Thanks, Sava. Here's another one. How does stemming play into the deep learning? Should it be based on a stemmed field or a raw field?
It should be on raw field. Generally, deep learning models, I would say, doesn't always like such heavy preprocessing as stemming or lemmatization. So yeah, and they can infer such things like similar words or words ending with S or whatever by themselves just by learning.
Great. There's a few questions related to versions and upcoming releases. So I'll just repeat something that I mentioned at the top of the webinar. This QA functionality that we're showing now is in preview. We are working with a very small number of our customers right now to test this, but it will be available in an upcoming release sometime this summer or early fall. So I got a few questions about when can I get my hands on this. There was another question: is any of this in Fusion 4.2, or is all of it still to come? Either one of you want to take that? I know pieces of some of the things you've shown might be enabled by 4.2 capabilities. Is that true, or is all of this still future looking?
Yeah, so right now we are offering this as in the form of a pilot, and it's not generally available until later this summer, but the actual pilot itself runs on top of Fusion 4.2. And then when this is GA, I think we plan to integrate it as in a future version of Fusion. I can't tell you exactly which version that's going to be, but for now they kind of run side by side. So this training module and Fusion 4.2.
And Andy, maybe you can take this one too. How does this QA relate to the open NLP processing in 4.2?
I would say they're conceptually related, but in terms of feature-wise, they're for different kinds of use cases. So the NLP annotation feature within 4.2, it integrates OpenNLP and Spark NLP annotation features like part speech tagging and name entity recognition into the query pipelines and index pipelines. So if you want to do stuff like extract all the entities from my documents and index them into a separate field, you can do that within using this particular feature. So I would say that the question answering system that we're introducing today is for different use cases. It's a lot more comprehensive and deals with actually answering questions, full-on long queries, and using your existing frequently asked questions as potential answers to your questions.
Hey, Andy, if we could stay on the topic, Andy or Sava, if we could stay on the topic of integration with other systems. I just got this question. How easy is this to plug into third-party models?
So I guess I would have to know a little bit more about what third-party models you're talking about. So Fusion does offer the ability to run TensorFlow models that you've trained outside of Fusion. So that could be an example of a third-party model. I guess I would have to understand more about which models you would like to integrate with.
Great. Whoever asked that question, please give a little bit more detail, and we'll come back to it. Here's another one. How might this FAQ solution work with a service such as Google Dialogflow?
That's a great question. I'm actually not super familiar with Dialogflow. If it's pretty similar to a lot of these chatbot solutions, I think and if it's a rules-based approach, you can definitely use our FAQ solution as one of the question answering models that might get triggered under some certain circumstance. But unfortunately, I don't know a ton about Dialogflow, and I'm not equipped to answer that question. I don't know, Sava, are you familiar with Dialogflow?
Not very, but generally, we're thinking about integrating it with some chatbot solutions, but that's all that I can say right now.
All right, well, look for more on that, and if that questioner wants to follow up with more detailed questions, go ahead and send those in. Here's another one on another data source. Do you have plans to crawl and index Microsoft Teams?
So we do have an extensive suite of different connectors. And again, I may not be equipped to answer this question. I'm not sure what the state of them are and whether or not we have a Microsoft Teams connector. But that's something that we can definitely try to find out for you.
Yeah, and I can pile on more generally. We do have more than 100 pre-built connectors, and we also have a connector kit, development kit, that people can use to connect to other sources that we don't have pre-built connectors for. And from all the conversations I've had with customers, that's worked well for most other sources that people want to bring in. Here's another question. I think there's lots of interest, guys, in the cold start solution. Can you expand on the cold start solution? And the question is that I see pre-trained word-to-vec embeddings are used, but how do you handle the natural language understanding tasks needed to handle producing question-style responses?
Generally, we can use already shipped embeddings, or word-to-vec embeddings might be trained on your unsupervised data that doesn't have any labels. And then we are using some tricks to actually combine word vectors to the question or answer vector. And those deep representations can actually handle some simple natural language understanding things, but for sure it doesn't work so great as trained deep learning model.
Thanks, Sava. A question on data size. I know in some of your slides you were referring to a small training set, and I think this question is connected to that. How much content is needed to get the DL model to work? For example, the number of docs or the size of docs. Can you guys talk a little about small, medium, large training sets and how you think about how you would measure those?
So I know this answer will be deeply unsatisfying, but it depends on the data. But in the charts that I was showing, there were 3 bars. One was 10%, 50%, 100% of the data set. So the total size of that data set was around 20,000 Q&A pairs. So 10% of that is about 2,000. And we've actually seen pretty good results on hundreds of Q&A pairs. And again, it really depends on the domain and the size of the conceptual space that you're trying to cover with your Q&A solution. But yeah, I mean, these aren't we're not talking about a million data points. And I think a lot of people, when they think deep learning, they think, oh, you need tons and tons and tons of data. This particular solution does not require a ton of data in order to get a good amount of value out of it. And part of it, too, is being able to utilize pre-trained embeddings and using that transfer learning approach to kind of bolster the lack of data points that we have.
Thanks, Andy. Back to the cold start scenario, should the model be retrained as new content becomes available from forum posts, blog posts, doc updates, et cetera? Talk to us about ongoing maintenance of models and retraining timelines.
Yeah, generally in cold start scenario, we assume that it would be a starting point, and then we can leverage some Fusion functionality to actually gather some signals, and you convert them, send them to the labeling data, like question answering pairs, and actually use them for training exactly supervised deep learning model.
All right. Could query time entity recognition be used together with your deep learning approach with Solr to enhance the overall QA system?
The answer is yes, it can be, although I would say probably in most cases it may not help or may be more trouble than it's worth. So one thing that I mentioned when talking about how we trained a traditional LTR model using these kinds of features like part-speech tagging and named entity extraction, we weren't able to get any better accuracy using these features as opposed to using the deep learning model. So again, one of the nice things about deep learning models is that you don't have to do a lot of this fancy feature extraction in order to get a good model. It kind of the deep learning network is able to encode and capture that information automatically. So you can. There may be some domains where it could help. But yeah, I think there are different considerations there too, and it may be more trouble than it's worth.
Lots of good questions around the size of data needed to training. I know you've both answered this in a couple different ways already. Let me know if this is a new variant of that question. Specifically around QA pairs for training a model, do you need multiple QA pairs related to the same topic, or is each QA pair a single example for training? I don't know if I'm translating that question correctly or explaining it correctly.
Generally, yeah, it might be just QA pairs in variety of topics. It doesn't matter. It might be one question and several appropriate answers, or several questions and one answer. So yeah, one to many, many to one, many to many. Our system is capable to understand what kind of pairs you are providing and use them for training.
Here's a question. It's interesting to see so many questions about the different types of data sources that might be indexed and incorporated in the QA system. Here's a question about Slack. Please talk a little bit more about how you would integrate Lucidworks with Slack and how that might make knowledge extraction better than it currently is.
Yeah, so Slack offers an API for you to get the compositions out, and it would be necessary to do some massaging of the data, because not everything in Slack are in the form of questions and answers, and so there are some pretty simple tricks that you can do to kind of try to extract query answer pairs from Slack data, whether it's using different threads or looking at some character level clues, and then from there just feed that information into the training module that we have. And so Slack, people have a lot of ad hoc conversations, and a lot of information gets lost in the ether, and it's hard to really access that information at a later point. So yeah, this just gives you another way to try to extract that information or extract value out of that data and capture all the variation of different questions and the way that questions are worded and the different answers that are available within your Slack channels.
I'm getting a few questions. How can I be added to the preview or beta test group? How can I talk to somebody about giving this an early trial? Questions like that. We will provide that information at the end here and also in a blog post that will be coming out either tomorrow or the next day. So for those of you that are asking about getting more involved directly with this technology, we'll definitely get you clear guidance on that. Here's one. What does the training network look like? Sequence to sequence? Question mark? Either you take that one?
Yeah, sure. No, it's not sequence to sequence because basically we are using pairs with answers that are already good in terms of how they answer the question. And generally, it is a CMS network that we're training on.
Here's another one. Where can we go to learn more about XGBoost, D2V, and DL simple triplets?
Well, you can probably find our previous webinar on this topic, and we covered a bit more details, classical algorithms like XGBoost, etc., and as well as deep learning model, kind of the same variation of it we are using in this pilot mode solution.
I'll pile onto that. We'll include a link to the recording of the previous deep learning webinar we did a few months ago in the blog post about this webinar. By the way, the blog post for this webinar will include the complete recording, so if you have friends or colleagues that are interested, they can watch the entire replay in the blog post that'll go live this week. Here's one that we haven't covered explicitly. I think we might have covered it in answer to another question, but you guys can let me know. Can we only use Virtual Assistant for specific topics and not use it for the entire website information? How does that work out? How much and how broad of information would you put into a QA system like this versus keeping it more focused on specific topics?
Again, it depends on your input data, and there's no right or wrong answer to your for this question. Because certain topics are very, very broad, and then some others are very specific. But I mean, in general, I think if there are certain topics where people tend to use similar vocabulary or similar words to describe different concepts, then it's probably better to kind of segment it that way and train a model for that given topic. So, for example, you wouldn't want to train it on like all of Wikipedia, for example. But you know, I think again, it kind of depends on your domain, and the nice thing about this training solution is that it does output a good amount of metrics in terms of how well the model is doing in classifying the data that you're giving it. So, so I think you can kind of use that as a way to guide you. And if you're not getting the accuracy that you want, then perhaps it is because your training data or your input data is a little bit too diverse or varied.
The questions keep coming. Here's another one. After starting with the cold start method, is there a recommended tipping point when you have sufficient data to train a model with gathered QA pairs?
Well, as Andy already mentioned, we can start to experiment with several hundreds of examples, but for sure, the more data you have, then it's better. Yeah.
Well, I believe I'll give one last call for any other questions. I believe we've gotten through all of them. Let me just repeat a couple of things for the audience. There will be a blog post this week with some more detailed written content on some of the topics that we've spoken to today. There will also be a link to our previous webinar on deep learning that had some different subtopics of this main category. And we will also include information about how to reach out to us and express interest in being part of the pilot or getting an early look at some of this QA system technology. One location that I want to, one easy answer to that question is you can go to our website and contact sales. And once you do that, we will put you in touch with the right people to find out what you need, what you're looking for, answer any questions you might have, and give you a clearer sense of the timeline for GA on this capability. We'll have a clear idea of the GA availability in the weeks to come, and if you get in touch with us now, we'll of course keep you informed about that. On behalf of the Lucidworks team, I want to thank everybody for taking time from their busy day and asking so many great questions. I want to thank Andy and Sava for taking all the different curveball pitches that we threw at them with questions. Oh, here's another question. So I'm glad I was took a couple more seconds on the goodbye. Here's a question. Is there an industry standard in regards to success rate when it comes to being able to correctly extract and understand user intent with virtual assistant and NLP? Any rules of thumb about what success might look like? And I'm guessing that the answer might be something related to it depends, but let me not answer the question for you guys. Any rule of thumb there? What do you use to determine whether it's successful or not in terms of understanding intent?
I mean, all I can say is that query intent or these kinds of techniques have been used in the industry and have been used successfully in the industry. And it just comes down to like doing the work of testing and measuring. And you know, I think part of success is having a realistic expectation of what information your data could capture, and then running experiments or running these kinds of metrics like the things that our FAQ solution provides, and examining the results, and then, you know, if things look good on paper or after some testing and, you know, doing some A/B testing to make sure that that you're getting the results you want in production. So you know, I think that's what makes some of this work kind of challenging, and we're trying to provide tools to make it easier for everybody to deploy these kinds of models and to make you guys be successful. So yeah, just measure early and often.
All right, I do want to respect people's time. We're just a couple minutes before the top of the hour. I'm sure there will be more questions, so go to the contact sales link on lucidworks.com if you have other questions. We will take those through that channel, and we will answer as many of these questions and others that have come up in the blog post, and that will also include information about contacting us to get more information. So this time is final. I want to thank everybody for joining. Andy, Sava, thank you so much, and look forward to speaking with you all again in an upcoming Lucidworks webinar.
Thank you.
Thanks, everyone.